Hey, what's up, everyone? How's it going? It is a fantastic Monday already. I love that our chat is already getting filled. How's everyone doing today? Is everyone ready to learn about pattern matching? All right, I am going to jump right in. So, today we are going to be learning about pattern matching, and we're going to be heading over to the Getting Started guide. So let me go ahead and switch my view here. And we'll open up our browser. I'll make this a little bigger for everyone. And we'll go to elixirlang.org, jump over to the guides, and we are on pattern matching today. All right. How is the text? Everyone is good. Can you read it? What's up, default? All right. So in this chapter, we will learn why the equal sign operator in Elixir is called the match operator and how to use it to pattern match inside data structures. We will learn about the pin operator, the caret, used to access previously bound values. All right, so the match operator, also known to most people as the equal sign, is like we've used it a few times now, right? To assign variables in Elixir. So let's go ahead and open up our terminal. And I'll make this a little bigger for everyone. And we'll start our Elixir shell, IEX. And now if we do x equals 1, we've done this before, and then if we type in x here, we get the value 1 back. So in Elixir, the match operator is actually the match operator, the equal sign is called the match operator. And now we'll go through this example below that kind of shows us why it's the match operator. So we have our variable x set to 1. So if we do 1 equals x, we get 1 back, okay? And if we do 2 equals x, we get a match error. So no match of the right-hand side value 1. So you notice that 1 equals x is a valid expression. And it matched because both the left and the right side are equal to 1. When the sides do not match, a match error is raised. So a variable can only be assigned on the left side of the equal sign. So if we do something like this, 1 equals unknown, we're going to get a compile error because unknown is an undefined variable. It has not been set to anything. So that's a little preview of the match operator and how it works. What's up, Connie? Good to see you, man. All right, so let's go down this list now, and we're going to go into the pattern matching section. So the match operator is not only used to match against simple values, but it can also be useful for destructuring more complex data types. So for example, we can pattern match on tuples. So let's go ahead and run through this example as well. So when we pattern match on a tuple, we can do something like this. We can, inside of our curly brace, we can have an A variable or a parameter name variable, B and C, and then close those curly braces. And then we can set them equal to 3 values of any kind. So we could do our hello Adam. We can do a string for world, and we can even pass in an integer. And when I hit enter, it's going to return our tuple with values. And each of those variables are now pattern matched, and they carry the value in the order that they were matched in. So if I type in A here, we're going to get our add hello back. And B, we're going to get our string world back. And did I say Atom world? I mean, Atom hello. I feel like I just did. I don't know. And then if we do C, we'll get our integer back. So that's pretty cool. And now a pattern match error will occur if both sides can't be matched. So if the tuples are different sizes, for instance, we're going to get a match error. So if I go back through something like this and I just remove this third value and we're trying to match 2 values to 3 values, we get our match error. Okay. So also, when comparing different types, for example, if a matching tuple on the left side with a list on the right side, you'll get a match error as well because they're different data types. So if we did something like this, our A, B, and C tuple, and we try to pattern match with a list. So if we do the same thing as before, but with a list instead of a tuple, we are going to get a match error. And square brackets, another match error. So let's go back to the documentation. All right, so more interestingly, we can match on specific values. The example below asserts that the left side will only match the right side when the right side is a tuple that starts with an atom OK. So we've talked about this in previous videos. You can pattern match for certain results using like conditional statements, like a case statement or other things like that. So we can also set a value here instead of a variable name that, you know, we're putting a value in. And so if it matches, it will return the tuple back to us, right? But if it doesn't match, you'll get a match error like this below. So see how we're trying to match an OK atom to an error atom, we get our match error. But up above, since the OK atom equals or matches this one, we get our result back. And then it automatically will save our second value in our tuple to our variable result. So let's go ahead and test that out. I'm going to clear this so we can see better. So let's go ahead and pattern match. So if we have a tuple with an OK atom and then result, which is a variable name, we can pattern match, and as long as we have an OK here, it will work. So now when I hit enter, we get our tuple back. And if I type in, if I want to see the value of result, it should be 13. So that's pretty cool. And so now if we do the same thing, but let's say we have an error here instead of a value, and we'll copy the example here and do an oops atom. We're going to get a match error because error does not match our OK. So that's pretty cool. You can kind of see how pattern matching is pretty powerful. It's pretty cool. Let's see if we have any no questions currently. All right. Whoop. Going to my code. All right. Let's go back to, so we can also pattern match on lists. So we can do the same thing as we did with the tuple, but with a list as well. So let's go ahead and try this out. If we go ahead and make a list with A, B, and C inside for variable names, A, B, and C, and we set this equal to another list with values, this will work. And we can go through each variable again. So we can see A is equal to 1, 2 is 2, or I'm sorry, B is 2, and C is 3. A list also supports matching on its own head and tail. And I know we talked about head and tail notation, I think in the last video. Taking off a week really throws off my schedule. Yeah, we talked about head and tail because we did lists and tuples. So it also works. So it's pretty much, so the head and tail is pattern matching. So the head is automatically the first item of the list, and the tail is the rest of the list. So we can run through an example again. And if we just make a list with head and then the cons operator, tail, and close that list off. And then we can set this equal, or we can pattern match to another list with values. So 1, 2, and 3, and hit enter. And we get our list back. But now when we want to see what our head value is, we see that it's 1. And if we want to see what our tail value is, we see that it's the remaining part of the list. So that's 2 and 3. All right. So similar to the HD arity1 and TL arity1 functions that we touched on last time, we also can't match an empty list with head and tail pattern. So let's go ahead and try that out. So if we do head and tail and send in and try to match an empty list, we get our match error back. Okay. Now the head and tail format is not only used on pattern matching, but also for prepending items to a list. And so, yeah, we touched on this in the last video as well, or the last live stream. So let's go ahead and do this. So let's create a variable called list, and we'll set it equal to a list with 1, 2, and 3 inside. And now we can prepend with the cons operator. And it's pretty much similar to pattern matching because we're just prepending the value. Anything on the left side gets added to the beginning of our list. So if we go ahead and do value 0, cons operator, and then our list, we are prepending 0 to the front of our list. And then we get our list back with 0, 1, 2, and 3 inside. All right. So pattern matching allows developers to easily destructure data types such as tuples and lists. As we will see in the following chapters, it is one of the foundations of recursion in Elixir and applies to other types as well, like maps and binaries. So yes, you can pattern match to maps and binaries as well. And what's nice is it allows you to write functions where you can pattern match for specific values. And what's nice is you have like your base function for recursive calls, and you can iterate through lists and everything with just multiple functions with parameters that are passed into the function to pattern match. It's really cool. All right, head and tail. No, so head and tail does not work with tuples because it is a fixed length. So you have to know the index of the value that you're retrieving. All right, so the pin operator. Variables in Elixir can be rebound. So when you set x equals to 1 and then you do x equals to 2, x is now 2 because we don't have access to the previous variable name. We're not really overwriting it, but it is the most recent like space and memory that we have access to for that specific variable name. So if we do x equals 1 and then say x equals 2, x is equal to 2 for us. And I'm going to clear so we can read again. And so, however, there are times when we don't want variables to be rebound. So you can use the pin operator when you want to pattern match against a variable's existing value rather than rebinding the value. So we can do, sorry guys, getting caught up. So if we do something like x equals 1, and then if we use the pin operator on x and say equals to 2, we're going to get our match error because the right hand side is obviously value 2, and since we use the pin operator, we're pattern matching against x instead of rebinding it. So x is still equal to 1. So when I hit x, it's still 1. So because we have pinned x when it was bound to the value of 1, it is equivalent to the following of doing 1 equals 2, and that's a match error. So notice that we even see the exact same error messages. So that's cool to notice, right? So right-hand side is 2, it does not match. Right-hand side is 2, it does not match. So we can use the pin operator inside other pattern matches, such as tuples or lists as well. And so we'll run through this example, and you can pin here. So yeah, this is really cool. Let's just go ahead and jump into an example right away. So x is equal to 1 still. And if we wanted to pattern match, we can say, all right, pin operator x, and then we can say comma, and then we have value 2 and 3, and then we'll close off our list, and then we can pattern match to a list with 1, 2, and 3, and we're going to get our list back because it matches, because our value of x is 1. And then we can even do this with tuples. So we could say y, comma, and then let's pin operator x, close that curly brace, and then we can equal to another tuple with 2 and 1. And this will pattern match. So not only did it use the match operator for 1, so 1 matched x, we also set a variable y to 2. So that's pretty cool. And then we can also do things like, if we do the same thing here, but we have x, or our second tuple value, 2, we'll get our match error because we have x pinned and x is a value of 1. So because x was bound to the value of 1 when it was pinned, this last example could have been written as a tuple with y comma 1 equals 2. So that makes sense. Let's go ahead and just run through that. So what we did up above with the pin operator, it's the same as writing it. It's the same as writing it as y1 equals 2 and 2, and obviously we get a match error because 1 does not equal 2. All right, so if a variable is mentioned more than once in a pattern, all references must bind to the same value. All right, so here we have x equals 1, 1, and so obviously x would equal 1 in this case. And if we try to have another variable or another value assigned or rebound to x, we're going to get a match error. So let's go ahead and run through that. Clear. So obviously we can do x equals the same values of a tuple, 1 and 1, because x equals 1. But x can only be bound to once. And if we try to do the same thing, curly braces, x, and then if we say equals 1 and 2, we get our match error because the right-hand value is 1 and 2, not 1 and 1. All right. In some cases, you don't care about a particular value in a pattern, and it is common practice to bind those values with an underscore. For example, if only the head of a list matters to us, we can assign the tail to an underscore. And this is nice. So anytime you pass in, parameters into even a function, you can do underscore in front of a parameter name, or just a underscore with no name after it. I always like to do like an underscore parameter name just so people know what it is, but then they can see that we don't use it because the underscore is in front of it. So let's go ahead and play around with this example. So in this case, we can do head, cons operator, underscore, close that square bracket for our list, and then we can set it to another list. So 1, 2, and 3. And so now we have head, but we don't have access to the tail. And so like what I was saying is I like to do this just for documentation as you read your own code. I would do something like that. And that is the same thing as just doing an underscore. So the variable underscore is special in that it can never be read from. Trying to read from it will give us a compile error. All right, so if we go back to the terminal and we try to read tail, it's used after being set. A leading underscore indicates that the value of the variable should be ignored. So that's a nice little warning for us. We didn't get an error though. Let's see if we call our underscore. There's our error. Okay, so we get a warning if we use a variable name after the underscore, which is good, I think. And then we get an error if it's just an underscore, because then the values are ignored. Look at that. I learned something new today. And so although pattern matching allows us to build powerful constructs, its usage is limited. For instance, you cannot make function calls on the left side of a match. The following example is invalid. All right, let's see. So we can't do, all right, see how we have a function here, length. They're expecting length of 3 coming back. You can't pattern match after that, which makes sense. But let's try it anyways. So if we do length and we have a list inside 1, 2, and 3, close off that square brace. All right, so if I hit enter right now, we get 3, but then if we try to pattern match to 3, we get an error because it cannot invoke a remote function inside of a match. So this finishes our introduction to pattern matching. As we will see in the next chapter, pattern matching is very common in many language constructs, and they can be further augmented with guards. Okay, head and tail. All right, I'm going to post this to general in Elixir Slack. Awesome, Paulo. Thank you. There is a gotcha with underscore vars. When there is trailing values after the var, it is a valid variable, but gets discarded. Awesome. Thanks, Paulo. That is good to know. I guess I never really realized that, but I like that we got our warning, and then we also got our error. I think that is good stuff. Let's see. Also, okay, underscore. Let's try it. A tuple underscore underscore tuple equals tuple with values 1 and 2. All right, but yeah, now we wouldn't have access. Yeah, that makes sense. I like that. And then if we'll just copy Paulo's examples here. High and high, match error. Okay, awesome. Thank you for the addition. I love that. So this is awesome. So that's our introduction to pattern matching from the Elixir Getting Started guide. And yeah, thanks for joining and thanks for chatting. I love when everyone gets involved and we talk and we go through the Elixir Getting Started guide. All right, guys. Well, thank you so much, and I appreciate you guys being here. I'm going to be doing a second live stream. I think I'll plan it for Thursday. I don't know. I feel like Monday, Wednesday. Yeah, probably Thursday. So I'll do, what is our next one? We're going to be using case, condition, and if statements. So that is fun. So yeah, I will see you guys on Thursday in the next Elixir Getting Started live stream. Thank you so much for being here. I appreciate you guys. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.